Hi guys, this is Mr. Chun, and this video is about geometric series and the applications of them. Okay, so our lesson objectives are to find the sums of geometric series. So we've talked about sequences, now we're moving into series and how to find their sums, and then also to find specific terms of those geometric series. Okay, so let's start with this idea. Let's say you found a funny joke online and you decided to email it or Facebook it or somehow share it with 3 people. Okay, so you send it out to 3 people, and those 3 people, so let's say you sent it out on Monday, and then on Tuesday those guys read it and they decide to send it out to 3 more people that they knew. So they send it out to 3 people, this guy sends it out to 3 people, and this guy sends it out to 3 people. Okay, so if we start counting the number of people who read the joke, on the first day you have 1, that's you. On Tuesday you have 3 people, and then on Wednesday you have 9 people. Okay, so you can see that this is a geometric sequence. The numbers will continually increase by a factor of 3. Okay, so the common ratio here is 3. And let's say we want to find out, well, how many people will have heard this joke by the following Monday? Okay, by next week Monday, the next Monday, how many people will have read the joke? Okay, so well, obviously you would have to start adding the number of people that read the joke every day. So let's start with 1. On the first Monday we have 1. On Tuesday we have 3. On Wednesday we have 9. The next day we would have 27. The next day you'd have 3 times that, so you have 81. The next day you have 243 plus 729. Okay, so that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then on the last day you'd have 2,187. Okay? So if you add all those numbers up, you would end up with 3,280 people will have read this joke in 1 week. Okay, assuming that this continues. Right? So you can see that this is actually a geometric sequence, right? In this case, it's actually a series because we have plus signs. These plus signs make this a series. So this is a geometric series. Okay, it's a geometric series, and the sequence of numbers actually follows this pattern, right? A sub n equals a sub 1 times r to the n minus 1. Okay, and more specifically for this it would be 1 times the common ratio is 3, and so we would have n minus 1. This would be our formula for the nth term of this sequence or series. Okay. Now we can notate this just like we did with arithmetic series. We represent it with this notation right here. We can say the sum of the first 8 terms, 1, 2, 3, 4, 5, 6, 7, 8. Sum of 8 terms is this. And let's try and make this a nice, let's see if we can find a formula, or a formula for finding the sum, like that will work for all geometric series. So what we can do is, let's see, what can I do with these numbers to make them disappear? Try and make as many of these numbers disappear as possible so that we have a nice, easy formula to use. Okay, well, if I multiply everything here, if I multiply all of these numbers by 3, what happens? So let's say I multiply everything, both sides, by 3. What happens to this side? Well, this side, if I multiply multiplying this whole side by 3 would be the same as distributing that 3 to each of these terms. And so it would be like multiplying 1 times 3 plus 3 times 3 plus 9 times 3. And so you can see that there's going to be a pattern. 1 times 3 is just 3, right? 1 times 3. 3 times 3 is 9. 9 times 3 is 27. And you can see that there's a pattern going on. These numbers actually just repeat. Okay, and that's kind of nice. So we have 2187, and then the last number, of course, would be 2,187 times 3. and that is 6,561. Okay, so we have this now. Now what can I do to this side to make some of those numbers disappear? Well, we can see that there's 3, 3, 9, 9, 27. Let's see if we can subtract these numbers from here. Okay, if we subtract this top line by this bottom line, we're going to get some nice cancellations. Okay, so on the left side, you're going to get 1 minus 3 times s sub 8. On the right side, you're going to get 1. 3 minus 3 is 0. 9 minus 9 is 0. That goes to 0. That goes to... Notice that we're subtracting, okay? I'm subtracting this whole side. We have 0 here, 0 here, 0 here, and we have the last term. Okay? So if I divide both sides by 1 minus 3, okay, if I divide both sides by 1 minus 3, what I end up with is s sub 8 equals 1 plus 6, 5, 6, 1, all over 1 minus 3. So let's take a closer look at these numbers. This 1 came from up here, and that was my first term, so that's a sub 1. This came from over here, and this actually is a sub 1 times r, which is 3, to the power of 8. Okay, so this is actually a sub 1 times r to the power of n, okay, in this case. And this term, this 3, turns out to be that came from over here, that's my ratio, so that's my r. So your formula actually turns out to be s sub n equals a sub 1 minus, whoops, sorry, this should be a minus. That right there should be a minus. Okay, that should become a minus. So we have a sub 1 minus a sub 1 times r to the n all over 1 minus r. And that is my formula for the sum of a geometric series. Okay? So here it is in a little more organized form. This is the sum of a geometric series, or this is another form of it where I've just factored out a sub 1. All I've done is factored a sub 1 out from the numerator. And obviously r cannot be 1, so my common ratio cannot be 1, or else it won't work because the denominator will go to 0. Alright, so let's try this problem. The question says, contagious diseases can spread very quickly. Suppose that 5 people are ill during the first week of an epidemic, and each person who's ill spreads the disease to 4 people by the end of the next week. So that means it's kind of like the opening problem that we talked about with the emailing of the joke. Okay, so each person is going to spread their disease to 4 people by the end of the next week. By the end of the 10th week of the epidemic, how many people have been affected by the illness? So this is actually going to be, because it says how many people have been affected by the illness, that's going to be a total number that we're looking for, and so we'll be looking for a sum. And because each person of those 5, each person will be spreading their disease, it is a geometric, because it'll be 5 times 4. So let's take a look. This is geometric series. The first term is 5 because we start with 5 people. We're growing at a rate of 4, and n, being the number of weeks, is 10. So we're just going to use our formula and just plug these in. And so here we start with our sum formula, a sub 1 times 1 minus r to the n, all over 1 minus r. Remember that this n is inside, this n must be inside my parentheses, and it applies only to the r. And we just plug those in, and we end up with, oh, that should say s sub 10, sorry. S sub 10 is equal to 5 times 1 minus 4 to the 10th, all over 1 minus 4. And if you do that on a calculator, you'll get that S sub 10 is equal to 1,747,625. Okay? So that's how many people would be affected after 10 weeks if this spreading rate continues on. Okay, so here's another problem. This time we're given an S and we're looking for an A sub 1. So we're given an S, so our formula is still going to be this, A sub 1 times R to the N all over 1 minus R. So we're still going to have this formula, but this time we're just looking for A sub 1. Okay, so we just plug these in. We end up with 39,360 equals A sub 1. And let's make that, I'm going to use the form that has, I'm just going to use this form, okay? So this becomes 1 minus 3 to the power of 8 all over 1 minus 3. And this simplifies to 39,360 equals A sub 1 times, if you do this on your calculator, you'll get minus 6560 on top and a negative 2 on the bottom. This simplifies to A sub 1 times 3,280. And if we divide both sides by 3,280, we get A sub 1 is equal to 12. Okay? So there we have it. We've found A sub 1 in this geometric series. Here's another example. Let's have you try for a minute. Pause the video. Try and find A sub 1. Notice that this time R is negative 2, so be careful when you use your formula, and check your answer after you try this. Okay, you should have found that S sub 7, because we're still going to use our formula, we still have A sub 1 times 1 minus R to the N all over 1 minus R. This time we have 258 over here because of that. And we're looking for A sub 1. We have 1 minus negative 2 to the power of N. N here is 7. So we're going to use a 7 right here. And we do 1 minus negative 2. Okay? And if we simplify this, we get 258 equals A sub 1 times 129 all over 3. And 258 becomes then A sub 1 times 129 divided by 3 is 43. And if you divide both sides by 43, you will get A sub 1 equals 6. Okay? So that's going to be my first term in this sequence, in this series. Okay, now here's a problem for you to think about. So far we've found the sum of a geometric series. Know if we've been given the first term and the last term and the common ratio. But what if we don't know the number of terms? So let's say we don't know what n is. What can we do? This becomes a difficult problem because then we have to start using logs to figure it out, and it gets really messy. So an easy way you can do this is to use this formula right here, and this is the alternate sum formula. So I'm just going to have you write that down. Please make a note of this. What is different about this? Well, the original formula is S sub n equals A sub 1 minus A sub 1 times R to the nth power all over 1 minus R. Okay, so the difference here is in this last term here. This last term, and this is actually equal to this. How do I know that? Because if I start from this equation, and this is our geometric nth term of a geometric sequence formula, If I go ahead and multiply both sides by r, what I get is I get a sub n times r equals a sub 1 times r to the n minus 1 times r. Okay, so what is this? What does this become? Well, r to the n minus 1 times r to the 1, that becomes r to the n minus 1 plus 1 using our laws of exponents. Those will cancel, so we actually end up with r to the n. Okay, so that whole expression right there becomes r to the n. And because these are the same, we can substitute, instead of this, we can substitute this, because this is the same. So we just take this number, put it right into here, and that's how we get this formula. Okay? So this is the an alternate sum formula. If you don't know what n is, but you do know what a sub n is, then you can use this. Let's try this. So let's try this one more time. This time we know what a sub 1 is, 15,625. We know a sub n is negative 5, and we know r is negative 1/5. And we're supposed to find s sub n. Okay? So how do we find s sub n? Well, if I tried it using this formula, if I try it using my normal formula, I run into a problem because I don't know what n is. So I'm going to use my alternate formula, and we end up with a sub 1 minus a sub n times r all over 1 minus r. Okay, and now it's just plug and chug. S sub n equals 15,625 minus negative 5 times minus 1/5 all over 1 minus negative 1/5. Okay, the top part, that goes to 1. So we end up with 5,624 on top. This bottom part, because we have 5 over 5, and that becomes a plus, so we end up with 6 over 5. And if you do the math here on your calculator, you will get S sub n equals 13,020. Okay, and that is the answer to this question. Find the sum of the geometric series. Okay, so that's it. Here's your homework. Please try it out and let me know if you have any problems next class. All right, thank you guys for listening. Bye.